Welcome pre-cal students to the video today, the review video for your final exam. Matthew Caleb, please listen carefully. If you want 5 bonus points, then I need you to take notes. And sorry about that. I need you to take notes on today's video, notes on Wednesday's video, and notes on Thursday's video, and turn those notes in when you turn your test in, okay? So that's how you're going to earn your 5 bonus points on your final exam, and 5 bonus points is a lot for a test. That's 20% of your final grade. So take some really good notes, please, and let's get started. We're going to spend the entire video today looking at graphing problems that will be on your test. So I am going to give you a problem on your test that says use the slope-intercept method to graph this equation. Now, whenever I ask you to use the slope-intercept method, the first thing you do is you get y by itself. So bring the 2x over and make it negative. Now divide everything by 3. And you should get this. Now, once y is by itself, your constant term is always your y-intercept, or we call that b. Negative 2/3, the number with the x, is always your slope, and we call that your m. Okay? So with that in mind, let me go ahead and grab this. And let's not do that. Let's grab that. And let's go ahead and graph this equation. So we know the y-intercept is 5, so I'm going to go to 5 on the y-axis and put a point right there because my y-intercept is 5. And then my slope is negative 2/3. Now don't forget, your top number is your rise and your bottom number is your run. So I'm going to put my pin right here. Notice my top number is 2, so I'm going to rise 2. I'll put a dotted line, go up 2. And then my run is 3. Now you either go to the right or you go to the left. Because your slope is negative, you will go to the left. And so I will go this way. I went up 2, 1, 2, and now I'm going to go 3 to the left and put a point there. And there we go. There is the line of that equation. That's using the slope-intercept method. Okay? Now, let's take a look at the next problem that could possibly be on your test. I want you to graph a linear equation using this double intercept method. The double intercept method. So the equation is 3x plus 2y equals negative 6. 3y plus 2x equals a negative 6. Now, what you do is you first of all put 0 in for y, and that will give you the x-intercept. 3 times 0 is 0. 0 plus 2x is 2x. Divide both sides by 2, and the x-intercept is negative 3. Now, next we will put 0 in for x, and that will give us the y-intercept. 2 times 0 is 0. 3y plus 0 is 3y. Divide both sides by 3, and y equals negative 2. Okay, so it looks like on the x-axis we're going to go to negative 3 and put a point there. On the y-axis we'll go to negative 2 and put a point there, and then sketch your line. So there's your line. Okay, there we go. Good enough. Moving on. I want you to graph this problem here, number 10. I want you to graph using a table of values. So we have 4x minus 3y equals 12. And what I've taught you to do when you're graphing a linear equation using a table of values, you can pick any 3 values for x that you want. I usually use 0, 1, and 2. If you put a 0 in for x, you'll get out negative 4. If you put a 1 in for x, you will get negative 2 2/3. And if you put a 2 in for x, 8, negative 8, 4, you'll get negative 1 1/3. Now I did that pretty quickly in my head, but I believe that's correct. And so now let's go ahead and let's plot those points. One ordered pair. Well, let me go and get my tick marks up here very quickly. Okay, one ordered pair would be 0, negative 4. The other ordered pair would be 1, negative 2 2/3. The next one would be 2 and negative 1 1/3. And they do line up in a straight line. And there's your line. Okay, so what we looked at quickly was graphing a linear equation by using the slope-intercept method, double-intercept method, and the table of values method. Okay, and by the way, on your exam, Caleb, Matthew, you guys are going to have to be able to look at problems and know what kind they are. Linear, like this one here that we're going to do now, this is a circle equation, and you've got to recognize that, okay? That's very important that you can recognize this. And how do I know this is a circle equation? Well, first of all, I know it's a circle equation because notice, hold on one second here. What I have is a parentheses with an x and then a squared, a parentheses squared with a y, and there's no number in front of the x, like a 2x or something like that, okay? So this is the form of a circle equation. Now, I need you to find the center of the circle and then the radius, and then you can graph it, okay? So let's review how to find the center. The center for this circle would be -4, +1. You change the sign of your x number in the x parentheses and change the sign of the number in the y parentheses. Now, in order to find the radius, you always take this number over here and you always take the square root of it. So sometimes you'll get out a decimal, sometimes you'll get out a whole number. The square root of 9, of course, is 3. So in this case, we have a whole number. Okay, so let's go ahead and graph our circle. And if you really feel like the 5 bonus points are not worth taking notes on all this, that's fine. That's really your decision, okay? But I do feel like it is. Okay, the center of the circle, -4, +1. There's the center of the circle. And then if the radius is 3, go over 3, 1, 2, 3, put a point there. Go up 3, 1, 2, 3, put a point there. Go over 3, 1, 2, 3, put a point here. And then go down 3, 1, 2, 3, and put a point there. And then you'll have a decent, not perfect, but a decent sketch of the circle that is represented by this circle equation. Okay? All right, moving on. Let's take a look at a piecewise function, which is next, and you should recognize these. And there it is. On the test or a quiz. And by the way, do you notice how these are all different numbers? That's because I just cut and pasted them off of tests. So you have all of these on your test, by the way. If you'll go back and get out your tests from this semester, these are problems from previous tests, okay? All right, let's go ahead and graph this piecewise function. Now, the first thing you do is you write the pieces. The first piece is y equals -x. The other piece is y equals 1/2 x plus 1. And I got that from right here. Y equals -x, and then y equals 1/2 x plus 1. So there's your two parts. Now notice for this part here, your x values are going to be less than 0. Notice for this part here, your x values are going to be greater than or equal to 0. Now, we're going to do a table of values right here, and even though x is not equal to 0, we're still going to start at 0, and there's going to be a hole. There's going to be a hole in the graph there. So my x values would be 0. Then we're going less than 0, so -1, -2. Okay, so if we put a 0 in for x, we get out a 0. Put a -1 in, we get out a +1. Put a -2 in for x, and we get out a +2. Now circle this point. That's where there's going to be a hole in the graph, because look, there's no equal sign there. Okay, now we come over here, and we go ahead and write our table of values. And notice my domain is x is greater than or equal to 0. So with that in mind, I'm going to put a 0, then a 1, then a 2. Well, if you put a 0 in, you get a 1. If you put a 1 in, you get a 1.5. And if you put a 2 in, you will get out a 2. And so now we're ready to go ahead and plot these points and sketch our graph. Now remember though, when you're graphing a piecewise function, both pieces that you're going to graph, they don't go in two directions. Each one goes in one direction. For example, I'll do this one in red. We have an open point at 0, 0, and then a closed point at -1, 1, and then -2, 2. You put your pen on the first point right here, and you go toward the other points. You do not go like this and put it both directions, okay? Now let's go ahead and use blue for this graph. I would have 0, 1, that's a closed point, 1, 1.5, 2, 2, and then here's your first point in your table of values, so you put your pin here and then go this direction. Okay? Alright, let's move on. Next we are looking at graphing a couple quadratic equations. Now this is a quadratic equation and you should recognize that. Okay? So here's what we do. When you're asked to graph a quadratic equation, the first thing you do is you find the vertex using this formula here, negative b over 2a. Alright, so b is negative 10 and a is 5. So what I end up getting is positive 10 over positive 10, which is 1. Now that's part of your vertex, okay? So part of your vertex is 1. Now I'm going to put a 1 in everywhere there's an x, and I'm going to get 5 minus 10 plus 3. I should get out a negative 2. So let me pause and get a drink here. And let's go over this again. Whenever you're graphing a quadratic equation, you first find the vertex by using negative b over 2a. That's part of the vertex. Then you take that number and put it in for x and get out a y, and that's the rest of your vertex. Now, if that's the rest of your vertex, then what we do now is we use a table of values, and we put our vertex right in the middle. So the vertex goes right here. I would go up to 2 and 3 and then go down to 0 and negative 1. Now let's put a 3 in real quick, and I will try to do this quickly. I don't have my grapher with me, so what I'm going to do is just quickly do it in my head here. Put a 3 in, that's 9, that's 45. Put a 3 here, that's negative 30 plus 3. So we should get out 18. Okay? Now let's put a negative 1 in, and we should get out 18 for that also. Negative 1 is 5. And that's a positive 10 and then a positive 3. So yes, we would get out 18. Now let's substitute 2 in for x. 2 squared is 4 times 5 is 20. Minus 20 plus 3 gives you a 3. And if you put 0 in for x, you'd get 0 minus 0 plus 3. So we do get a 3. Okay, so we're looking pretty good on our graph. Now, I'm not going to expect you to graph a point that's positive 18. Okay, but that does just tell us the graph is really high there at that point. Okay, our vertex would be at 1, negative 2, and then we go over 2 and up 3, and then 0, let's see, over 2, up 3, and then 0, 3 is right here. And then the other 2 points, 3, 18 is way up here somewhere, negative 1, 8, would it be negative 118? Let's see. 3, 1, 2. Yes, this point right here is wrong, and I apologize. This is 0, 3. So this point right here should go right there. There we go. And then negative 118 is way up here somewhere. So you have a really skinny parabola is what you have. And please don't draw it with a V. It'll come down, it'll be rounded, it'll come back up, and we have a real skinny parabola. Some are wide and some are skinny. So it's just how it is. So there we go. Okay. So that's how we graph parabolas or quadratic functions. And I know I'm going pretty fast, but I mean, we've learned all this. This is just review. Okay. Now, this is also a quadratic, and you need to recognize this form because on your test, I'm going to mix all of these equations up. You're going to have one big section that's going to say graph the following numbers, and you're going to have to graph them all and recognize each type. So get a good look at this. We have an x and a number. Quantity squared with a number here and a number here. This is a quadratic equation, so when you graph this you will get a parabola. However, it's in vertex form, so finding the vertex is really easy. The vertex would be negative 3, positive 4. And we got that because whatever this number here is, you always change the sign, and whatever this number here is, you never change the sign, and that's how you get your vertex. So that's really, really simple. That's a lot easier than using negative b over 2a. Now, let's go ahead and put our vertex right here. I'm going to put a negative 2 and a negative 1, then going down a negative 4 and a negative 5. So let's put a negative 1 in, put a -1 here, you get a 2 squared is 4. -8 plus 4 would be a -4. Let's put a -5 in. Hopefully we'll get a -4 also. -5, that gives you -2 squared is 4, -8, -4. Now we'll put a -2 in. That's 1, -2. You get out of 2. If you put a -4 in, you also get out of 2. So there we go. I'm doing these very quickly, but men, Matthew, Caleb, we should definitely know by now in a pre-calculus class how to substitute values in and get out y values. Okay, so that should not be too difficult to do. And let's continue on. Okay, your vertex is -3, 4. And then one point would be -2, 2. Another point would be -1, -4. And then over here we have -4, 2. And then -5, -4. So you're seeing a really good form of a parabola here taking place. And there we go. Okay, moving on. Okay, now these are the ones that are pretty difficult. And first of all, I'm trying to think if I'm going to make you guys, well, first of all, let's take a look at this function right here. This is obviously a polynomial function, and it's already factored for you, okay? So we know that what we have is really this. And the steps I gave you were this. First of all, you want to find the x-intercepts, and of course the x-intercepts are always the zeros, and the zeros for this function would obviously be +1 and -2. So +1 would be one x-intercept, and then -2 would be another x-intercept, okay? And then also we've talked about multiplicity, and remember when you have an even multiplicity, that means like right here we have a -2 and a -2. We have an even number of -2s. So we know the graph is going to hit here and shoot back up, or the graph is going to hit here and shoot back down, okay? So what I've encouraged you to do is after you find your x-intercepts, plot points to the left, plot points in between, and plot points to the right. So if I put in a -3 for this equation, so using a grapher, I'm going to go ahead and go to way over here to -2, 3, 4, 5. At -5, I would get out, oh my, -1,944, so it's way down here. -4 would be -500. -3 is -64. So I know the graph is way down here. I know it's going to come up and hit here, and I know it's going to come back down. So let's see, at -1 it's going to be -8, so it'll be down here somewhere. And then at 0 it's going to be back up at -4. So it's hitting here, coming down, hitting here, coming back up. And I'm going to quickly, I could do the end characteristics, and remember how to do that. I love it when they're already factored for you. I think it's a lot easier. As for end characteristics, you have, I shouldn't have erased this, you have if you were to take x times x for your first two parentheses, you would get x squared. Then times this x would be x cubed. Then times this x, x to the fourth, times this x, x to the fifth. And your lead coefficient will be positive because all of your x's are positive. So if you were to multiply all this out, you would have a lot of work to do, but one thing we know for sure, your lead coefficient would be a positive x to the fifth. And of course, anytime you have a lead coefficient that has an odd degree and a positive lead coefficient, the end characteristics are down over here and up over here. So we're doing just fine. We know it's going to come up over here and continue up, so we're pretty good. Also, if it's a fifth degree, we know it will have no more than 5 zeros, and it doesn't. It has 2. We also know it'll take no more than 4 turns. You always subtract 1 from the degree, and it only takes 2 turns, so we're totally good, okay? Now, I think on your test, because we've done so many of these, and I know, Caleb, you don't have a grapher, I'm going to go ahead and leave these off right here. If I give you a polynomial function on your test, it'll be one that's already factored for you, okay, to save a little bit of time there. Okay, moving on to these here. Now these are the ones that we just did on our last test. Okay, students had to pause the video there. Let's see. We just graphed these on our last test, or the last 2 tests, I believe. And so I'm not going to do a lot of work on these for you. It's just on our last test. These are fresh off of your notes and off of your last test. I will say this to you. Let's go through each of these as in terms of the asymptotes. If your degree is higher in the top than the numerator, you have no horizontal asymptote, and you do have a slant asymptote if the degree in the numerator is exactly 1 more than the denominator, and your degree in the numerator is 2, your degree in the denominator is 1, and so you would have a slant asymptote. And remember, you would take the numerator, x squared minus 5, and divide that by x plus 2, and that would give you the slant asymptote. Put an x here, x squared minus or plus 2x, change the sign, negative 7x, x goes into negative 7x, negative 7 times. So take this negative 7, bring down your negative, let's see. Oh, on the division here, sorry about that, guys. On the division, negative 2x would not be combined with your negative 5. That's my fault. So you would just have negative 2x and then bring down your negative 5. And so x would go to negative 2x, negative 2 times. And then change your signs and add. We don't care about the remainder. So your slant asymptote would be y equals x minus 2. Okay. Now, remember the vertical asymptotes for this problem here would be negative 2, because you take the denominator and you set it equal to 0 and solve. Okay, so whatever I'm writing down, take notes on if you're trying to get the bonus points. Now, over here, really your degree is going to be x to the 0, and here if you were to multiply this out, you would get x squared. So the degree is higher in the denominator than the numerator, and that means you have a horizontal asymptote at 0. You have a vertical asymptote at positive 2, and there's no slant asymptote. Okay? Now for this one over here, your vertical asymptotes, if you factored this right here, you would get x minus 5, x plus 4. So your vertical asymptotes would be at positive 5 and negative 4. And then notice your degree would be the same. So your horizontal asymptote in this case would be 1, because you have a lead coefficient of 1 and a lead coefficient of 1. And whenever the degree is the same, your horizontal asymptote is lead coefficient over lead coefficient, and your lead coefficient is 1 over 1. So your horizontal asymptote is 1, and there would not be a slant asymptote. And then for this last one, again, we have a horizontal asymptote at 0, because the degree in the numerator is smaller than the denominator. And then your vertical asymptotes would be, if we factored this, we would get x minus 5, x plus 3, which would give us vertical asymptotes at positive 5 and negative 3. Now, I did not take time to graph each of these. Again, we have the luxury of having 2 students, and I know where you guys are at, and we just did these on the last test. So you should have your last test. They were just passed back to you about a week ago, and to be honest with you, we know what to do. I mean, if you have vertical asymptotes like here, like we do here in this last problem, at positive 5 and negative 3, then you should know what to do, guys. You would substitute values to the left of your vertical asymptote into your equation. So you would put in values like -4, -5, -6, and see what the graph is doing over here. I'm guessing it's probably doing something like this. I'm just guessing. Then over here, you would plot points between the two vertical asymptotes. So you would put in -2, -1, 0, 1, 2, 3, 4. And the graph, I'm guessing it might look something like this. Remember, horizontal asymptotes can sometimes be crossed. And then over here, I would put numbers into your equation like 6, 7, 8, 9, and maybe it's down here again. I'm just guessing and not being lazy, guys. I'm actually trying to help you and save you time. I'm trying to make these as quick as possible when they're problems we just had about a week or 2 weeks ago, okay? So make sure you know how to find vertical asymptotes, horizontal asymptotes, slant asymptotes, and then you know what points to plot when you're dealing with rational expressions, okay? Okay, 2 more equations. We're not going to do all 4 of these, just 2 of these. And of course, these were just on your test today that I gave you. So these are really familiar. If it's a logarithmic equation, you take the argument and set it equal to 0. So in this problem right here, the argument is x, and so we take the argument and we set it equal to 0, and that is how you get your vertical asymptote, okay? So all logarithmic functions have a vertical asymptote, and the vertical asymptote here would be 0. So here's my vertical asymptote. Now the vertical asymptote for this one right here, well, your argument is x plus 1. So if you set x plus 1 equal to 0 and solved, you get -1. So your vertical asymptote would be at -1. Okay? But back to this problem over here. Now what you would do next is you would use a table of values, and here's what you need to do. Either you're going to put values in to the right of your vertical asymptote or the left. Well, it wouldn't be to the left because these are negative numbers, so you would have a negative argument, okay? And so we're going to put numbers in like 1, 2, 3, 4, 5, and also we're going to put in 0.1. We're going to go barely past the asymptote, so we're going to put in 0.1, then 1, then 2, then 3, and then 4. Okay, so let me grab my grapher real quick here and type this into the equation here, and let's see what we get. We have log of x minus 2, and then let's see what we have. For 1, we would get out a -2. For 2, a -1.7. A 3 would be a -1.5. And you know what I'm thinking? I'm thinking these here, it's kind of funny. We can all laugh at Mr. Earhart because Mr. Earhart's really getting old these days. But I think I took these off of your test that you guys are doing right now. So basically, I was just helping you do one of your test problems, I believe. And so it's kind of funny. So this here is right off of the test that I gave you guys today. I'm pretty sure. Okay, I'm pretty sure. So let me just say this. I'm not going to make you take notes on these. However, I'm going to refresh your memory and say to you, when it comes to logarithms, take the argument, set it equal to 0, and that'll be your vertical asymptote, and then go from there. On exponential graphs, you're going to take the exponent, set it equal to 0, like this one here. X minus 3 equals 0, and then you'll get x equals 3. And what that ends up being is your middle value in your table of values. Okay, so you put a 3 here, and then whatever your constant term is, that's going to be your horizontal asymptote. So this one here, your horizontal asymptote would be at 4. I'm not going to say anymore. I'm pretty sure this is right off the test that you guys are taking tomorrow and Wednesday, so I'll stop there. But again, this is brand new material, so it should be fresh in your mind. On your final exam, you will have graphing logarithms and you will have graphing exponentials, okay? So know how to do those. You will have graphing rational expressions, know how to do those. And then also you will have graphing polynomial functions like this. They will be factored for you, so know how to do those. You will have vertex form of parabolas on your test, and you will also have standard form of quadratic equations, parabolas to graph. You will have piecewise functions on your test. You will have circle equations on your test, and you will be asked to graph linear equations by using the table of values method, the double intercept method, and the slope intercept method. Okay, so those are the graphing problems that could be on your exam, and I'm not sure if I'll put them all on there or not, but those are the ones you need to know how to graph for your exam coming up on Friday. Okay, so if you have any questions, don't hesitate to call or email. Okay, all right, have a good day, and we will talk to you guys on Wednesday.